So if you can remember in our last scraping video, we built a basic scraper, but that scraper was lacking in a lot of areas. So what I managed to do was to improve it, make it better, and also add certain features and also a Streamlit that will help us to visualize all our data and present it as a neat website. So as for now, let me run the Streamlit and show you what we've done so far. And as you can see here, I was just installing some of the required dependencies for our Streamlit to run properly. So before we get into what I changed about the code and the simple design of the Streamlit itself, here we go. As you can see here, our Streamlit is very standard. So we have simplifies product intelligence, and you have a little search bar with your analyze. So last time we were looking for wireless headphones, but to show you that it works with more than just the wireless headphones, here we can try something else, like let's say you wanted an electric toothbrush. In the search bar we type electric toothbrush. Okay, remove the space between the tooth and the brush and analyze. It will take a moment to scrape everything, and in the background our initial code is running, the one that's doing all the scraping. And when it's done running all of that, our Streamlit will just get all those sections of code that have run and the outputs from those sections of code, and it will display it to us as the complete product intelligence tool. So we decided to go with a little bit of a simple output form factor here with the Streamlit, because yes, you can do a lot more with it, but also Streamlit is direct and it's one of the easier Python libraries that you could possibly use. So if you're just looking for something simple and something that you can easily modify and adjust, yeah, Streamlit is one of the best ways to carry out this, for this particular purpose, to carry out this particular task. So yeah, if you would like to watch us do more with our scraping code, leave a like and comment down in the comment section, and if we get a particularly good enough amount of likes and comments, we can use our scraper tool. We'll turn it into an API, and we will use JavaScript to continue and build out a powerful website that will analyze and get our products for us. Okay, so now that our analysis is complete, here you see price statistics. So from Amazon, you can see platform count, minimum, maximum, mean, median, standard, and the range. So from Amazon, the count that we found about 41, and the minimum is $5. The maximum is $379. The mean is about $91. The median is about $59, and the other metrics, the standard and the range. And on eBay, the value, the counts are a little bit more, not a lot more. So now we come down to the next table, competitive analyses. So for the competitive analyses, you get the platforms, so the budgets, the mean for the budget around $83, $85. The count is 40. For an economy price, you find these toothbrushes for about $379. That's on Amazon, and there's no mid-range or premium price. And on eBay, there is no budget. So if you're trying to look for expensive type of electric toothbrushes, for the economy price, you'll get $1,177.78. Yeah, the price of the toothbrushes. The mid-range is around $2,425.26, and for the premium toothbrushes, electric toothbrushes, it's about $8,094. All right, and so we also have price predictions. So for the index of 158, 159, 160. So that's the lower side of things, because this data is also grouped in a sort of a table, and then the analysis is conducted from the table, right? Because when we're using our matplotlib and other visualizations through Python, well, basically web scraping through Python, we use a model of documentational analysis. So we collect these pieces of data from the websites, Amazon, eBay, and we put them all in one document. And then from that document, we extract and receive the data. So here you can check out from the document itself, there's index number 58, and that should be the one that should boom next, because the predicted price is at 8,000, we could say 8,300, and the model score is 0.75. But since it's the one that carries, well, it's cheaper, so it carries more resale value out of all of these 4 elements. Yeah, it's the cheaper one, so it carries more resale value. So let's say you buy it for 8,300 and you're selling it for 8,568. You get at least a $269-68 return from that resale. All right, and let's move on to the visual insights. So here, this is the price distribution over the platforms. So you can see that over time, they had boomed from the count between, that should be about 20. Yeah, from the count of 20, they were booming up, and then as the price as the price increases, the quantity decreases. So there's that. And then there's price comparison between Amazon and eBay. Between Amazon, since there's not much variation to it, you can see that the scatter is close to the bottom line and there's not really too much motion there. And when we move on to eBay now, you can see that at least there are variations and variants to the products you can get. And you can see that we have this small box here on the center, the red box, and this shows where a lot of the buys are occurring and a lot of the progress is, because that's, and of course you can see the other values like outside the range, a little bit further outside the range, but yeah, those are just some of the elements that were picked up by our scraper. And also here's another price prediction using the R-squared score. So here our squared score is 0.58, and for this score we can see that we have the actual prices, those the green dots, the price trend, it's going up, and predicted prices. So over time with the product indexes, it would be ideal to stick to the prediction, because if you get the product for cheaper and you stick to our predicted plan here, so this is taking mostly based off of the eBay prices. Our line here where the stars are the predicted prices, that's closer to about 5,100, 5,200 US dollars. So if you were to get something lower than that and sell it for that amount, you would basically hit a sweet spot, a sweet point in the scaling of it. Now that I've shown you what we can do and how the code itself works, let's go back and see what has changed about the code itself. Okay, so here's the code, mainly the scraper code. So I use the custom Cyclify CSS. This is mostly just to determine the colors of a Cyclify feel, our Cyclify colors, but you can use any other colors you would like to use. And yeah, moving on, this is the UI. So the title itself, Cyclify Product Intelligence, you can change it. Markdown, this is just the extra text, the description of it. And yeah, analyze Amazon, eBay products, trends, real-time scraping, forecasting, inputs. So this is our search box. And now that you have your input, and also in the input we have our starter text, so the text that will come up whenever you write, whenever you start the Streamlit. And next, this is the functionality for the button. So we're using an if statement, and what this does basically is it starts a spinner while we're waiting for the data itself to come up. It starts the spinner, and while the spinner is spinning, the data is loading. So basically that basic functionality where the spinner spins while data is loading, and when the fetch of the data is completed, now we have the subheader for the price statistics, the competitive analysis subheader, the price prediction subheader, and under that also those are the predictions that will be collected over time. So from our data frame, this is where it goes. And then the render plots, it gets them from our main scraper module that we have improved. And also, if you'd like, I did choose to add an optional save HTML and embedded. So you can see on the left side here, it has the HTML. All right, now to the main thing. This is our scraper in comparison with the last one. So I'll put them side by side so that you can check them out in comparison and see what actually differs. All right, so we've added a configure login. So I don't remember if we had a configure login in the other video, but I will put a side by side. So a configure login and a list of user agents. So if you don't remember, what these do is they basically handle which websites and what type of websites that a web driver is going to work around or work with mostly. So as you can see, we have decided to use Mozilla as the base. So for Windows, for Macintosh, for Windows again, and also for Linux, so that you can basically manage to run this code on any system. So next we have our product scraper. There's a little more variation in comparison with the first time that we created the scraper, because at first we just wanted to basically handle that as a starter. Like I said in that video, we were just starting and we would improve it and create a better scraper from that. So this is the evolution of our scraper. So basically the same functionality, but it does a little more. We initialize our Selenium drive for drivers. We download NLTK data from sentiment analyses, and then we set up the driver, so the web driver, so that it can go through these websites. And also, if you remember from the last video, I said the reason that we do this, like setting up headers and all of that, is because these websites are built to handle bots. So if we want our scraper to run efficiently off of these websites without getting booted out, we need to basically program our scraper in a way that will emulate human and natural movement alongst the site. All right, so now that we've finished with the setting up, here's the headers and the making of the request. So completing the headers themselves, like I explained, just so it feels natural, it feels like an actual human moving through the site. Here we start to make the request itself. So you try the attempt using the headers and you get the responses. And also here, by adding delays, you can see here, respecting websites by adding delays, so that it feels like a natural human movement. We're humanizing our code, basically adding a little bit of a delay so that it doesn't seem too quick and like it's a bot. We add a timer so that our delay has a little bit of, a delay to it as well, for it to push in another request. So here we have our logger. So this logs all the errors that have happened throughout the retrieving and the making of the request. And then here is where now we handle the mathematical side of things. So like I said, we handle all of this data by creating an artificial type of database. We create our own database from the products that we're scraping. So here we get the prices, and when we get the prices, we replace the dollar signs with blank spaces and the commas with blank spaces, and replace US with blank spaces as well, because when we're scraping, we're getting the value of the products in the US. All right, so this is mostly for the US market. After that, we handle the price ranges to take the lower prices. So we use if and else statements to help us do that. And then here we do a little bit more of the mathematical side of things while we're properly handling the float integers in this. And we're matching the prices to the search, and also another logger for the warnings and errors. Here, basically what we're trying to do is, even though we have an exemption, but we're trying to find where our code has problems. So if our code is running, but still there are some issues that the code is giving us, we use this by logging the errors so that we know where the error occurred. So if you've noticed, in each section of the code, we have a logger, so we know where and where not an error is happening. Moving forward, here's the new scrape eBay. Basically does the same thing, but again, we improved it, we made it beefier, we made it stronger. Now it can handle all of those few problems that we had. Well, not few, but it can handle those problems efficiently. Moving on, we're getting things like the shop items, we're getting the ratings, and we're also getting the shipping information, because we're gonna need all of this information to determine which product is booming, which ones are preferred by the customers, and also we're gonna use all of these pieces of information to create a proper prediction. Also, we have another logger just so that we know which products and, well, whether the scraper side of things is working properly. And also, if let's say we have a problem processing a particular item, that's there. We have our beefier scrape Amazon function. And here again, same thing, we've added more delays, a little bit longer delay, and we handled most of the little problems that we said that most of the other scrapers that you'll find on YouTube, on the internet have, because most of these scrapers do not have enough value. They don't give enough, they don't do enough because they're basic. And as a person that wants to create this type of scraper for a portfolio project, let's say, you need something that will give more value, something that will show that you're capable of handling a little more than the basic stuff, because you want to position yourself in a way that you're far ahead of your competition. Because yeah, anyone can build a basic scraper, but your scraper should be able to do more. So this is what we did with this code. And moving forward, we added some random scrolling to mimic human behavior as well. We combined the whole and fraction parts of the price, extracting the ratings and extracting the review count, and also adding if only we have a valid price, and the random delays between the pages, just so that we're mimicking that human behavior. And this is why when we run our code, it takes a little bit longer to get everything, because we're trying to make it seem as human as possible so that we don't get kicked off as a bot on these websites. Okay, so here's the define function for the random scrolling. After that, we have our close, so with a logger there. The last part, we come to the analyses. So here we get the data from Amazon and eBay. So we've been storing them in these data sets called Amazon data and eBay data. We store them in there. So now what we're going to do is we'll start by bringing out the databases, and then we clean them, see if there's invalid data, missing values, and then we start to work on each of them, also handling things like duplicates and also categorizing the columns, right? And then we log the data shape, and then we start to get the statistics now, the mathematical side of things. After we've gotten and cleaned all the data, we start by getting the minimum, the count, the maximum, the mean, the median, and the standard, and adding the price ranges of everything so that we have the range. And to get the range, we have the max and the minimum. So everything between the max and the minimum, that's our range. And then we get the competitive analyses. So this one is just a simplified approach that looks at average prices in each category. So just the average prices. We predict the future prices. Here we use the minimum data points, and then we sort the prices and then create a future index or future indices, and then calculate a confidence matrix. At the end, this is what we get when we create visualizations, and we turn all of our data, all of the data that we've scraped for the statistics, the competitive analysis, and also the full data itself, we put it all in one place, and then we share that visualization. And next we have the visualizer. This uses basic Python libraries like matplotlib and seaborn to help us to move forward and show what we have as findings from our data as visual diagrams. So we have the visualizer, and then this is basic setup stylings here, and we have price distribution and price distribution by platform. We're distinguishing each distribution by its platform. Some of the diagrams, and we move into plotting and adding vertical lines for mean prices, and we plot the legend, the tight layout, and the save figure, and then creating a box plot here. We'll plot the figure, and here we're using seaborn to plot it as a box plot. We add swarm plot for individual points for the swarm plot, and here we have the titles and the labels, and also the visualization of each of the two websites. So we have the visualization of Amazon and also eBay for each one. So we have the visualization for both Amazon and eBay, so the two colors there. And then we go for the swarm plot. These are for the little dots that were in the graph that has the red box in the center. So it's called the swarm plot. For the swarm plot, here are some of the plottings. So plotting the layout, labels, and everything, and creating a price prediction chart. Here are the methods of visualizing that, and plotting the regression line and actual prices, and then the prediction. You label them, and then you add the confidence area. So for this, we're using scikit-learn, and we'll use the mean square error. We visualize the mean square error, we plot the grid, and this gives us our perfect grid as a PNG. Here we're plotting interactive plots, and they also make their own subplots. So price distribution against price versus rating. And here we are. Below that, we also have a box plot in the first subplot and a scatter plot in the second subplot, an update layout with updated axes. Here at the end, we also export to an HTML file, and then we have our main, which basically handles and calls out everything to run properly and in the right order. So this is our main. We have all of our analyzers, our scrapers, and also what should come and be displayed when we run our code. and also our logger, the visualizations, exemptions, finally, and here if name, main, run. So on the other side of things, our Streamlit visualizes everything as part of one little website. But if you come here, you can see that you have the HTML file, you have the box plot as well. It is exported as PNG, an image, and press distribution as well. It is exported as an image and price prediction as well as an image. So what our Streamlit does is it takes in account all of these things that the code exported, and then it presents everything and all of the other findings as well into one neatly presented form of a website using the Streamlit library. So again, if you want to use this code and create somewhat of a website that you deploy using JavaScript, you can leave a like and comment in the comment section below so that we move on and we turn this into an API. We host it online using, of course, using free resources, and then we run it and then deploy it as our own JavaScript website. For more of these types of projects, subscribe, click on the notification button, and I hope I will sickify you later.